Whenever we speak about dialysis, we hear three words again and again. Those are diffusion, convection, and adsorption. Let's see them here with simple real life analogies. Imagine you dip a tea bag into hot water. Inside the tea bag, the essence is highly concentrated. Outside, the water is almost empty. So slowly, tea begins to spread from the high concentration inside the bag to the low concentration outside. And if you look closely, you'll notice something. The small tea molecules travel far, forming a light brown cloud, while the larger tea molecules stay closer to the bag. This simple everyday scene exactly is diffusion. And most part of our dialysis works the same way. Here, the blood contains urea, creatinine, potassium, and the dialysate has almost none of these. So these toxins naturally move from blood to dialysate. But here, we should also not lose useful ions like sodium, chloride, calcium. So these ions are essentially maintained at physiological concentrations in the dialysate, so that there is no net movement of these ions into either of the compartments. And similar to the tea leaves, blood cells, albumin and other larger molecules do not get into the dialysate site because of the pore size. To sum up, in diffusion, only solutes move. There is no net water movement, and the solute movement depends on concentration gradient. Also, smaller solutes travel faster, while larger solutes take a longer time. And just like the water outside the tea bag never becomes as strong as the tea inside with a limited contact time, the toxins in the used dialysate, that is, the effluent, never reaches 100% of the blood concentration. So now let's move on to the second concept, convection. Now think of making a lemon juice and pouring it through a filter. Now when you pour it, everything right from water, sugar, pulp and seeds, irrespective of their size, gets carried along by the water flow. Here, whatever that goes through the filter gets transferred while the larger molecules stay behind. And that's convection. And to note, unlike diffusion, there is net water movement here, and the solute movement is directly proportional to the convection volume. Also here, the solute movement neither depends on concentration gradient nor on the particle size. In a similar way, in hemofiltration, we push water across the filter using pressure, and solutes get carried along in bulk regardless of the size. But here, not just urea creatinine, useful ions like sodium chloride also gets filtered. So we replace the convected volume with substitution fluid having electrolytes in physiological concentration. And if you look at the effluent here, it would have got the toxins at a concentration almost similar to that present in the blood. So the effluent saturation here is close to 100%. And finally, let's see adsorption. Here, blood passes over a special material, usually a charcoal or a resin, and certain toxins simply stick to it. So there is no dialysate and no substitution fluid. So that's it. Diffusion is tea spreading, convection is lemonade flowing through a filter, and adsorption is toxins sticking to a surface. Three simple mechanisms that actually make dialysis work.